How are you all? Hope you all are fine and doing well. My name is Naresh. Welcome to our channel Physics Plaza. Children, today we are going to start a new chapter, Calorimetry. So in this first we will learn basic and a very important concept called heat, temperature and their units and conversions. First let us see actually what is a calorimetry. Children, calorimetry we can see it as a combination of two words. It's a calorie and metry. Children, what is calorie here? Calorie is a most commonly used or a unit of heat. So heat is measured in terms of actually calorie. Here metry means what? Measurement. Metry means what? Actually it's a measurement. So here calorimetry means it's a measurement of quantity of heat. Children, it's very important. What is calorimetry? The measurement of quantity of heat is called calorimetry. Then what is heat actually? Then what is heat? Okay, if you can understand what is heat, then we can learn how it can be measured and what are its units. Children, in order to understand the heat concept, we need to go to the molecular level. We know that each substance is made up of with molecules. Let us suppose here a substance is considered with 6 molecules. 6 molecules only, it's just assumption only. So here substance is considered the 6 molecules. Children, the molecules in the substance, they are in random motion. At the same time, they exert some force of attraction. For suppose this molecule may exert some force of attraction on this molecule. At the same time, this molecule may exert some force of attraction on this molecule. Children, due to the random motion, the molecules, let us take only individual molecule. Here I am considering only this molecule. Only this one molecule I am considering. So due to the random motion, this molecule will possess kinetic energy. At the same time, due to the force of attraction, the same molecule will possess potential energy. It will possess kinetic energy and potential energy. Children, the sum of this kinetic and potential energy only, the sum of the potential and kinetic energy only, we can call it as a internal energy. We can call it as a internal energy. What is internal energy, dear children? The sum total of the potential and kinetic energy of the molecule is called internal energy. Which means what? Individual, if you can think, each molecule in the substance possesses internal energy. For suppose, the internal energy of this first molecule is, let us say it is I1. The internal energy of second molecule is I2. It is a I3. So like this, each molecule in the substance possesses some internal energy. Now what are we going to do? Now let us try to add all these energies. The sum, just try to do the summation of all the internal energies of molecules. Children, the summation of I1 plus I2 plus I3 plus I4 plus I5. Here as we have taken I6, like this n number of molecules will be there. So this total internal energy, so I can say it as a summation of I. From I is equal to, so summation of I means the total of internal energy of a molecules of a substance, only we can call it as a thermal energy. This we can call it as a thermal energy. Children, it's very important. What is thermal energy? What is thermal energy? The sum of the internal energies of all molecules of a substance. All molecules of substance. Children, look at here once again. Each molecule will have some internal energy. So try to add all the internal energies of molecules of a substance. Then you will get thermal energy. Children, here hot body. Let us take, here is a hot body. And here is, let us make it more clear. Here is a cold body. So this is hot body and here is cold body. Children, hot body is having more thermal energy and cold body will have less thermal energy. Then what will happen when these two bodies are in contact So here this is how actually, for suppose both are in contact. Then what will happen when both are in contact? The energy from hot body will flow to the cold body. So here energy is flowing. Here energy is flowing from hot body to cold body. Due to which what happens here? Cold body warms up whereas hot body cools down. Means what here? The thermal energy of cold body is increasing, whereas the thermal energy of hot body is decreasing. But how it is possible? How it is possible? Okay, let me make more clear. Let me make more clear. Look at here, children. For example, my right hand is a hot body, my left hand is a cold body, and these fingers are molecules. These fingers are molecules. Children, as I told you that here, hot body, more thermal energy will be there. So due to which the molecules are in vibration. Means they will be having a more vibrations here. Like they will be vibrating vigorously. Okay. Now, in cold body, just let us try to understand. In a hot body, the molecules are vibrating vigorously. So when this hot body is brought in a contact with the cold body, then what happens? The energy is given in the form of vibrations. So what will happen? These vibrations are passed so that cold body molecules starting vibrations, thereby energy is transferred. Children, the energy which is flowing from hot body to cold body when they are in contact is called actually heat energy, or simply we can say heat. I repeat once, heat always flows from hot body to cold body. Children, heat is like other forms of energy. Okay, it is also one of the forms of energy which always flows from hot body to cold body. But the thing is that as we are saying that okay, it is like other forms of energy, then how can we measure the heat? Then what are the units of heat? What are the units of heat? Let us see in detail. Let us see actually. Children, the heat is measured with a device called calorimeter. Calorimeter is a device which is used to measure the heat, means heat lost or heat gained. And here one more very important thing is, children, the units of heat. In SI system, heat is measured in terms of joule. Children, can I write like this? Joule. Can I write? No, it is wrong. I cannot write like this. Why? So whenever we are writing a units, whenever you are writing a unit, that to full name of the unit, the first letter must be small. You should be very careful. So here Joule. Symbol can be capital letter. Children, here actually we should get one doubt. The SI unit of heat is joule only. At the same time, the SI unit of work also joule only. Then both physical quantities are representing the same unit. Then why we should use two different terms actually? So what is a similarity between heat and work, and what is the difference between heat and work actually? Children, the similarity is that heat or work, both are like a, it's like a transfer of, in both, the energy transformation will take place. But difference is that work is a mechanical process, whereas heat is a non-mechanical process. That is a very important difference. I repeat once, work is a mechanical process completely, whereas heat is a non-mechanical process. Okay, children. And other than joule, the most commonly used unit of heat is calorie. Children, what is calorie? Let us discuss that. Children, let us consider here 1 gram of water. Let us take it as 1 gram of water. Let us say initially the water is at some 10 degrees Celsius. Suppose it is at 10 degrees Celsius. Now we want to raise the temperature of this 1 gram of mass from 10 degrees Celsius to 11 degrees Celsius. When it is possible? It is possible only when we provide some amount of heat. So this amount of heat provided or the amount of heat required only we can call it as a calorie. How to define calorie, children? Look at here. The amount of heat required to raise the temperature of 1 gram of substance, 1 gram of water through 1 degree Celsius is called calorie. But dear children, there is a problem here actually. Already in the previous classes which we have learned that anomalous expansion of water means water cannot expand equally at all temperatures. To avoid that problem actually, so in order to define the calorie, so the particular temperatures are defined. So we will take it from 14.5 degrees Celsius to 15.5 degrees Celsius. Now let us define. Children, please note down that the amount of heat required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius is called calorie. Children, if you want to measure the small quantity of heat, we can use a calorie. If not, the calorie will become very small. There we will use kilocalorie. There we will use actually kilocalorie. Children, kilocalorie. Kilo means 1000. Kilocalorie is equal to, it will be 1000 calories. 1000 calories. Children, how joule is related to the calorie here? We know that 1 calorie is equal to 4.186 joules actually, but approximately we can take it as a 4.2 joules. 1 calorie is equal to 4.2 joules. As 1 calorie is equal to 4.2 joules, 1 kilocalorie is equal to how many joules? Multiply with 1000. So children, 1 kilocalorie is equal to 4.2 into 1000. So it will be 4200 joules. 4200 joules. Children, this is what actually heat is and what are the units of heat. I repeat once. Heat is a form of energy which always flows from hot body to cold body, and its SI units are joules and the CGS units are calorie. How joules and calorie are related, dear children? How joules and calorie are related? 1 calorie is equal to 4.2 joules. Children, here we have learned very important definition called calorie. What is calorie? The amount of heat required to raise the temperature of 1 gram of water from 14.5 degrees Celsius to 15.5 degrees Celsius is called calorie. Children, here let us take, here is a hot body once again, hot body, and here is cold body. Here is cold body. When these two are in thermal contact, no doubt about it, heat is flowing from hot body to cold body, which means what here? Heat is losing the heat, hot body is losing the heat, whereas cold body is gaining the heat. Then can I say that the body which is like a hot body, we can say that the hot body, it is in a position to supply the heat, So the body which supplies the heat is said to be at a higher temperature, whereas the body which is in a position to receive heat is said to be at lower temperature. So here we are getting one more new term called temperature. Children, what is temperature? How can we measure the temperature? And what are the units of temperature? How can we convert units of temperature from one scale to another scale? First, let us see temperature. Children, it is a very common word. It is well known to us. Temperature. Let us see. First, we will try to learn temperature. Children, if for example, one body is shown to you, two bodies are shown to you like this. From far you are observing. Can you say that which is the hot body, which is the cold body? Of course, it is not that much easy to identify unless you touch it. Once you go and once you touch the substance, you can say. For example, when you touch the ice cube, you will say, my God, it's too chilly. Whereas by mistake, anytime if we can touch any hot body, immediately we can take our finger. My God, it's too hot. Means the degree of hotness, a degree of coldness, only we can call it as a temperature. The degree of hotness or coldness of a substance is called temperature. In detail, how can we learn actually? Children, here is body A, here is body B. The temperature of this body is, let us say, T1. The temperature of this body is T2, let us say, T2. And these both bodies are in contact. Both bodies are connected. Can you please tell the now direction of heat, whether heat will flow from body A to body B or body B to body A? No, we cannot unless and until we know the temperature of each body. We cannot. We know that hot body to cold body. Here, what is a hot body, what is a cold body? We don't know that. If here condition is given like this, if T1 is greater than T2, of course, now we can say that as temperature of body A is more than that of the temperature of body B, and it is a hot body and here is a cold body. So now heat will flow from hot body to cold body. Means here who is deciding the direction of flow of heat? Temperature. So the physical quantity which determines the direction of flow of heat, either heat should flow from A to B or B to A. Who is deciding here? Who is determining the direction of flow of heat? Temperature. Children, here temperature is like a director and heat is like an actor. So generally during the movie making, what will happen? Whatever the director will tell, actor will do it. The similar manner here, who is deciding the direction of flow of heat? It is called actually temperature. Now children, okay, for suppose it is at 50 degrees Celsius and it is at initially 20 degrees Celsius. Then no doubt about it, heat will flow from body A to body B. So this process is continued, but till what extent this process is continued? Till both bodies attain same temperature. For suppose the body A has reached like a 35 degrees Celsius and the body B also has reached to 35 degrees only. Still they are in thermal contact. Now in which direction heat will flow? No, heat cannot flow. Dear children, in this state, both bodies are said to be in thermal equilibrium. Both are said to be in thermal equilibrium. Please note, it's very, very important. In thermal equilibrium state, heat is not gained or heat is not lost. In the thermal equilibrium, body cannot receive heat or body cannot give a heat. Because already I told you that there must be some temperature difference. Then only there will be a flow of heat from one body to another body. How can we measure the temperature? Children, we know that the device called thermometer. Thermometer is a device. Children, thermo means what? Temperature. Meter is a device. The device which measures the temperature is called thermometer. Now let us see the units of temperature. Children, here to measure the temperature we have a different scales. In that the most commonly used units or like scales are Celsius scale we have, Fahrenheit scale we have, then we will have Kelvin scale also. But examination point of view, the relation between the Celsius scale and the Kelvin scale is very important. Let us try to discuss that. Children, the SI unit of temperature is Kelvin and the most commonly used unit of temperature is degree Celsius. So then what is the relation between Kelvin scale to the Celsius scale? How can we convert the temperature from Kelvin to Celsius or Celsius to Kelvin? If you want to understand this, we need to understand the relation between the different scales which is used to measure the temperature. Children, here we have three scales as I told you that here Celsius scale we have, Fahrenheit scale we have and here Kelvin scale we have. Children, in Celsius scale, the lower fixed point, that is at the temperature at which ice starts melting, it is 0 degrees Celsius, whereas in a Fahrenheit it is 32 degrees Fahrenheit, whereas in Kelvin it is 273.15, whereas the upper fixed point at which water boils in the Celsius scale it is 100 degrees, whereas in Fahrenheit it is 212 degree Fahrenheit, whereas in Kelvin it is 373.15. Children, here one very important thing we have to notice. Here 100 to 0, 0 to 100, how many divisions are there? 100 minus 0, so there are 100 divisions. Whereas 212 minus 32, how many divisions are there here? 180 divisions. Whereas here if you can see, children, approximately you can take it as a 273 and 370 enough. 373 minus 273, how many divisions are there here? 100 divisions are there. Children, this is a point which you have to notice. The number of divisions in a Celsius scale are equal to the number of divisions in a Kelvin scale. Then how can we write actually the relation which you have learnt in the previous classes? Let me write directly here. This is in Celsius case lower fixed point by upper fixed point minus lower fixed point. is equal to, in Fahrenheit scale, it will be lower fixed point by upper fixed point minus lower fixed point. And here it is in Kelvin scale, lower fixed point by upper fixed point minus lower fixed point. Let us simplify this. This will be C by 100 is equal to F minus 32 by 180 is equal to K minus 273 by 100. K 73. Children, please note down. It's very important. Now let us see how can we convert temperature from Celsius to Fahrenheit, Fahrenheit to Celsius, Kelvin to Celsius. Children, examination point of view just will discuss. First, let us try to convert the temperature from degree Celsius to Fahrenheit, Fahrenheit to Celsius. So in order to convert this temperature, equate these two terms, that is C by 100 is equal to F minus 32 by 180. Let us simplify this. 0, 0 cancel, 2 5s are 2 9s are. So it is C is equal to 5 by 9 into F minus 32. Children, this is a formula which is used to convert the temperature from Celsius to Fahrenheit and Fahrenheit to Celsius. It's very important. Example, here temperature is given in Fahrenheit. Convert, please write down, convert 932 degree Fahrenheit into degree Celsius, Children, in the place of F, you please substitute 932. Come on, do it. How much you will be getting? C is equal to, it is 5 by 9 into 932 minus 32, which is equal to 5 by 9 into 900. 9 ones are 900s. 5 into 100 will be, it is a 500 degrees Celsius. Children, this is how actually we can convert from Celsius to Fahrenheit. Here Fahrenheit to Celsius we converted. If temperature is given Celsius, in the place of C you can substitute, so that you will get answer in terms of Fahrenheit. Next, how can we convert the temperature from Celsius scale to Celsius to Kelvin and Kelvin to Celsius? Children, it's a very important. In examination also definitely there will be one more question. So in order to convert, equate these two. So here degree Celsius to Kelvin and Kelvin to degree Celsius we are doing now. So let us equate these two terms. It will be C by 100 is equal to K minus 273 by it is 100. Let me rub this. Hope you have copied. Yes. Children, it will be very interesting it is. So here 100 gets cancelled. 100 gets cancelled. So then here C is equal to K minus 273. Here if I write C and K, you will be having some confusion. Now here we will do one thing to make it more clear. Let us write here. So small t is a temperature in Celsius scale is equal to capital T is a temperature in Kelvin. Okay, minus 273. So it is a Kelvin. Let me write in a bracket. So this is a formula which we use to convert the temperature from Kelvin to degree Celsius. Or we can write like this. The temperature in a Kelvin scale is equal to, get this 273 this side. It will be temperature in a degree Celsius plus 273. So it will be more clear if we take one example. Let us try to solve it. Example, children, write the one example. Convert 10 degrees Celsius into Kelvins. Children, when you want to convert degree Celsius to Kelvin, plus 273 must be added according to this. Let us see here. So temperature in Kelvin scale is equal to, so what is the temperature given? 10 degrees Celsius. So here you can write 10 degrees plus 273. So it will be total 283 kelvins. Children, 10 degrees Celsius is equal to 283 kelvins. First, let us see one more example. Children, hope it is very clear. Fine. Convert 53 kelvins into degree Celsius. 53 Kelvin into degree Celsius. So remember that when we want to convert Kelvin to degree Celsius, minus 273. You have to do the minus 273. Let us take this formula, this one. So if you want a temperature in a degree Celsius is equal to temperature in Kelvin, that is 53 minus 273 minus 273. Children, how much it will be? I think 220, yes, it is a minus 220 degrees Celsius, minus 220 degrees Celsius. Children, this is how we can convert temperature from Kelvin scale to Celsius scale and a Celsius scale to Kelvin scale. Children, I have an important question. Come on, this you have to do it. Just do the question and comment the answer. Comment the answer. If the question is here, let us take a body, any substance. This body is imparted some heat energy. Some heat energy is given to this body, so that this body is showing the rise in temperature. Rise in temperature by 20 degrees Celsius. 20 degrees Celsius. Then here, what we can say, then can we convert here, means what is the corresponding temperature here? Then here, what is the, children please write down, what is the corresponding temperature? What is the corresponding temperature? What is the corresponding rise in temperature? Corresponding rise in temperature. Rise in temperature in Kelvin scale. In the Kelvin scale. I repeat once. An object is provided with some amount of heat, so that it is showing some rise in temperature by 20 degrees Celsius. Then for this 20 degrees Celsius, we have to calculate the corresponding temperature. What is the corresponding temperature? Corresponding rise in temperature in a Kelvin scale. Come on, do this. Children, here most of the children, they will, what do they do, you know? Yes, 20 degrees Celsius is equal to, already here we have done, right? 10 degrees Celsius into Kelvin means 10 plus 273. So here what they will do here, 20 plus 273 they will do it. So here they will get 283 Kelvin they will get. But children, this is wrong. Sir, why it is wrong? You only said that when you want to convert from 10 degrees Celsius to Celsius to Kelvin, 273 must be added. But here we have done the same way, 20 plus 273, we got 283 Kelvins. Yes, my dear children, but here is temperature we discussed, but here it is rise in temperature. Then how to find the corresponding temperature? Children, if you want to understand that, we need to understand the rise in temperature in a Celsius scale, whereas rise in temperature in a Kelvin scale. Dear children, the rise in temperature in a Celsius scale is equal to the rise in temperature in Kelvin scale. Not clear? We will make it more clear. Children, simple. For example, let me take two thermometers. Let me take two thermometers. Children, it is assumption. Purely it is assumption. So let us take two thermometers. Let us say here. So it is in a Celsius scale thermometer. It is Kelvin scale thermometer. Let us say here. So here it is the ball of thermometer, and here is. Children, this first thermometer is calibrated. Oh, this is not fine. No problem. La la la. Oh yeah. What is this? But sir, as a teacher, you only not getting. As a students, how we will make? We will get the children. We will get. It's not a problem. Yes, fine. Now, children, here this thermometer is calibrated in Celsius, degree Celsius. Let us say it is 1, 2, 3, 4, 5, 6, 7, like this up to. The last one is 100. Let us say it is 1, 2, 3, 4, 5, 6, 7. Okay. Whereas here also 1, just wait, 1, 2, 3, 4, 5, 6, 7 up to 100. But here this lower one is 0 degrees Celsius, upper one is 100 degrees Celsius. Here in Kelvin scale, lower one is 273 Kelvins, whereas upper fixed point is 373 kelvins. Children, already we discussed that what we discussed, the number of divisions in the Celsius scale are equal to the number of divisions in Kelvin scale. That is very, very important. Children, now these two thermometers are children, it is just assumption only, are placed are placed in like a, in a water, for example, let us say both are placed. So that what will happen, this both thermometers will read the temperature. Means what will happen here, first suppose example I am saying, it's not exactly in this, for example, mercury is there, some liquid is there. So either the liquid is in Celsius scale or Kelvin scale, as it is absorbing the same amount of heat, it has to show same expansion. So here let us say in like in a degree Celsius scale, let me make it more clear. In degree Celsius scale, the temperature, it is showing the rise is going like this, and at this fifth, after reaching this 5 degrees, what happened, it is showing the stable, it is showing the stability, simultaneously here what will happen, same thing happens here also. So it will take from here, so it will rise to 73, okay, like this it will show. So here also this is a rise in temperature, this will be how much, dear children, 278, whereas here this is how much, 5 degrees Celsius. Now calculate this change in temperature, 5 degrees Celsius minus 0 degrees Celsius, it will be how much here, 5 minus 0, it is 5 degrees Celsius. Whereas here try to find out the rise in temperature, 273 Kelvin to 278 Kelvin. So the rise in temperature will be 278 minus 273, it will be 5 Kelvin. Children, got it now? So here 5 degrees Celsius is equal to the 5 Kelvin. Children, either it is a rise in temperature or fall in temperature will be same in Celsius scale and as well as Kelvin scale. Here the rise in temperature in the Celsius scale is 5 degrees Celsius. So what is the rise in temperature in a Kelvin scale? 5 kelvins. If a fall in temperature in a degrees, what a Celsius scale is 10 degrees, then what is the fall in temperature in a Kelvin scale? 10 kelvins. So now you tell me the rise in temperature by 20 degrees Celsius, then what is the corresponding rise in temperature in Kelvin scale? It will be 20 degrees Celsius is equal to 20 Kelvin. Children, this is what actually we have to understand. This is a point where many of us, many students, they'll be doing wrong again. Children, please try to understand. Are you converting the temperature or are you converting the rise in temperature? That's very, very important. If you are converting the temperature from degree Celsius to Kelvin scale, you add plus 273, no problem. But when you are converting, what rise in temperature or fall in temperature, it will be equal. Why? The number of divisions in a Celsius scale are equal to the number of divisions in Kelvin scale. Okay, children, in this session what we have learned? We have learned what is calorimetry, what is the heat and the concept of heat and the units of it we discussed. Then the temperature and its units and a conversion from one scale to another scale we have learned. Children, next session we are going to discuss the factors affecting the amount of heat absorbed or rejected. After that, we will be discussing heat capacity and specific heat capacity. Okay, children, thank you so much. All the very best.